Hello all. In this video, we're going to take a very brief look at the work of Valentino Braitenberg and his work with Braitenberg Vehicles. This is a different way of imagining the internals of a reflex agent. So we've already seen sort of the if then else rule based reflex agent. Valentino Braitenberg's vehicles use a different method where sensors are connected directly to motors in the vehicles with just maybe some scaling happening in between. And he has a whole book of these sort of thought experiments about simple agents and then what their behavior would look like and how we might ascribe emotions or thoughts or reactions to agents that really have a very simple internal structure. So Braitenberg was a cyberneticist, and so he was interested in control systems and how they work. And it's kind of related to robotics, but also a little bit of its own thing. And I like the fact that he focuses on like how we perceive the behavior of these agents from the outside, because it is actually really common for human beings to anthropomorphize simple objects that move and behave in certain ways, and it's something to watch out for because you could be ascribing emotional states to something without actually knowing for sure that they are there. Anyway, let's take a closer look. We're only going to look at the first few of Braitenberg's vehicles, but if you find this fascinating, I do have the entire book, and you're welcome to borrow my copy and take a look some more, or go out and find copies of it out there in the world and take a look at his later chapters. All right, so here is Valentino Braitenberg. I wrote the name down in my notes just so you have it. What I have here is the example of his first and most simple vehicle. So the idea here is that the vehicle has a sensor at the front that senses values from the world. You could imagine that it's in water and maybe it's the temperature of the water. In his thought experience, he's often thinking of light. So this would be something where the sensor would report a higher value for brighter lights and a lower value for darker lights. At the back of the agent, you have a motor, a single motor, and it can run at different speeds, causing the agent to move at different speeds. So the question is, what happens if we hook the sensor directly to the motor? So brighter sensor values turn into higher motor speeds, and lower sensor values turn into lower motor speeds. You have to be careful when you implement this that that's actually how your system is going to work. So there might be some scaling that has to happen depending on what range of values. Since this was a thought experiment, Braitenberg didn't think about that very much. But it's interesting for the rest of us to think about. So when there's a lot of light, the agent will go fast. When there's not very much light, the agent will move slowly. What does that look like as this agent moves around in the world? Now, you say it only has one motor, so theoretically it's just moving straight. It's moving straight forward the entire time. But if you imagine that the world might not be flat or even, or it might be water where there are currents, you can imagine that in fact its movement may be not quite so straight and direct as we imagine it to be. But what you would see with this agent is that in bright areas, the agent would move quickly, and in dark areas, it would linger. So it might look very much like an agent who's afraid of the light, who prefers to be in dark places and not in light places, because it moves more quickly in one than in the other. So this is a very, very simple Braitenberg vehicle. We will actually be working to implement some of these. It's interesting to do this with a physical robot. It's also interesting to do this with artificial agents like the ones in NetLogo that we've looked at elsewhere. It is in constant movement unless you set it up so that at the lowest light levels it stops moving altogether. Otherwise, this might be seen as in constant movement, and therefore it's somewhat restless. Okay, now vehicle 2 has two variations. So what we've done is we've doubled the number of sensors and motors. We have two sensors. They are both pointed more or less forward, but you could imagine that they are actually pointing off to the sides, one to the front and left, one to the front and right. And we have two motors at the back of the agent. Once you put two motors on an agent, it can move in very complex ways. If you allow some of the motors to run backwards, which you could do, you can get even more complex movements and behaviors from this. But for now, we're just going to assume that the motors move the agent forward. They rotate in a forward direction. And it's mostly about the speed and the relative speed that the agent might have. So we have two different configurations here. This picture is actually taken from the Braitenberg book because he has lovely illustrations in the book. The one on the left, 2A, the left sensor connects to the left motor and the right sensor connects to the right motor. And in 2B, all we've done is to cross them. So the left sensor connects to the right motor and the right sensor connects to the left motor. It's a very simple change, but it really has an important change in how these agents behave. The 2A agent, supposing that it's like it is in this picture, there is a light source that is to the right of the agent. The right sensor is closer to that light source. It's going to read a higher light level than the left sensor. That means that the two wheels at the back will operate at different speeds. The right wheel will run faster than the left wheel does. Think through what happens if you have two wheels that are going at different speeds. If one wheel's going much faster than the other, then the robot, the agent, as it moves, is going to tend to turn to the left because that right side is will move farther in the same amount of time. The wheel spins more often. Try this out with an actual pair of wheels if you aren't sure about this. But in this case, the 2A agent, sensing a light to the right, is going to tend to move to the left. It's going to tend to turn to the left. It's still the case that if there's just generally high light around it, where both motors are getting more or less the same speed, it'll have a higher speed in brighter areas and a slower speed in darker areas, just like vehicle 1. But it also will tend to turn away from light sources. So this is going to be something that is afraid of light. It wants to get into a dark area. It's going to turn away from light. The 2B has different behavior because we've crossed those wires. So if you imagine the 2B to be where the 2A was, that's not how the picture shows it. If 2B had a light off to its right, then its right sensor is going to have the highest value, but that's going to go to the left motor and vice versa. So now we've switched which of the two motors is going to be faster in that situation. So this agent would turn toward the light. And you can see where it is placed in this diagram with a light to its left. That's going to make the left sensor brighter, stronger. That's going to make the right motor go faster, so it will turn towards the light. Now, this kind of seems like light-seeking behavior, and it is, but of course, if the light source is not something it can physically bump into, then it will go and pick up speed as it gets closer to the light, and then once it zooms past the light, it will maybe run away from it and end up slowing down in a darker area as well. But it does definitely turn towards the light as opposed to away from it. So Valentino Braitenberg was interested in then how would we characterize the behavior from the outside, not knowing necessarily that it's such a simple mechanism on the inside. And so you might see the 2A is more timid, the 2B is more aggressive. And those are our interpretations. But again, it's emergent properties that you see with these agents that are not necessarily reflective of the mechanism that's going on inside of them. All right, so this is just a very brief introduction to Braitenberg's vehicles. He has many, many more chapters with more complex vehicles that have multiple different kinds of sensors. And so there's a lot of interesting thought there about how complex behavior arises from simple agents. But even these very, very simple first examples are a great way to demonstrate that exact property, the emergence of complex behavior from simple mechanisms. What I also want to emphasize here is that this is a really different way of mapping sensors to actions. So instead of reading in the sensors and then having a bunch of if statements that determine how you behave depending on what the configuration of sensors values is, here they are directly, it's a mathematical function that translates sensor values into actions. And that is actually, that gives you a smoother set of behaviors sometimes than the alternative, because you don't have these disjunctive spaces where you're switching from one case of an if else to another. It just smoothly varies over time in a way that's kind of nice. So Braitenberg vehicles are a great example that reflex agent does not have to be table driven or if then else driven. It can actually just be a calculation that's done to map sensors to actions. I'm going to stop there and I will see you very soon.